Okay, Assalamualaikum. Hi, I'm sorry for the technical issue. So we will start again this ROF with Encik Ahmad Fairuz. So with without further ado, I will pass the floor to Mr. Ahmad Fairuz. Silakan.
Okay, Assalamualaikum and very good morning. So today, the knowledge sharing session. So I will share with you about the case study of motorized wheelchair design for disabled person with Tetra phocomelia with PPFD. Yeah. So in this project or in this grant, so the team there are few team involved, 5 of us. Okay. So and then the project introduction, problem statement. There's a need to develop an affordable motorized vehicle for better mobility. Okay, research aim to enable the user to manage their own mobility. Okay, hypothesis to use an affordable lightweight material to develop an accessible motorized vehicle for the user, which born without limbs and legs. Okay, the area of study. The study includes the feasibility study that existing use wheelchair, the system use, and the characteristic of the physical disabilities. In the study, the researcher will be overseeing and documenting the problem arise on the existing motorized wheelchair, which focusing on two areas. Which the first one is the main structure itself. Number two is design of the motorized wheelchair, which is not comfortable, unsafe, and less aesthetic. Okay, research area, the field research was also conducted to evaluate the existing wheelchair system in the market before start redesigning the wheelchair. Okay, the expected result of the study is to document the background of the needs of the characteristic. B is the available high-grade aluminum material will be used to support the mobility and the relevant properties. C, the design specification will be used as instrument data for the motorized vehicle. D, the selection of design features, documentation of design procedures, and result will be used to create a P.O.C. Okay. E, the outcome of will be observed and tested by the user. Okay, the grant achievement, the first preliminary prototype test and the data result in the first grant will be used to improvise the wheelchair prototype in the second grant. The second improved prototype will be undergo user testing in the area of reliability, stability of the system, and ease of usage. Significance of study, expected result. This study will show the benefit and knowledge combination between design arts and engineering science. Okay. Uh, the knowledge, the findings of the study will be used for disabled person of Tetra phocomelia with PPFD can be beneficial locally, regionally, and internationally. Number three, the intention of the study is to develop the human capital where any relevant of local SMI be able to participate in developing and producing the end product based on local design. Okay, design research projects, which here we got two grants. The first type of grant is proof of concept, which contain of grant funded by Yayasan Sultan Mizan. The grant value is about 25K. Project duration is about 10 months. Project starts from mid 2016 to 2017. So, and then the type of grant two is prototype working grant. So provide to produce a working prototype grant funded by Terengganu State of Government. So still 25K, and project duration is from 12 months February to December. To be presented to Sultan Terengganu, Tuanku Sultan Mizan, and Sultan Hassanariah. Okay, research process. So there are four main research process. The first one is to understand the characteristic of the user, which to identify other type of physical disability which close to tetraphocomelia, and method apply observation and recording data to evaluate the existing problem arise on the wheelchair design and system, which is refining the frame, refining the system, and reposition the control panel and up and down. Identify the existing mobility design system through field research and market study. Identify market segment, existing model in the market, reliability system, reliable and affordable material. Lastly, is to propose solution for PWDS with tetraphocomelia with PPFD on the reliable elevated system, reliable and affordable lightweight material, more comfort and ergonomic design. Okay, research design plan is to conduct research techniques, observation, or recorded an interview, okay, in the area of ergonomic, safety, functionality, and reliability, and user testing. Number two, to ensure the research finding meet the criteria, the design features and proposed system sets such as transportable, lightweight, ease of operate, reliable, elevated system. Number three, to attach an evidence of engineering science knowledge as a design specification in the form of converting data from 2D to 3D, converting STL file output to 3D printing, and preparation drawing for prototype making. So number four is to improvise the lightweight material such as aluminium, mild steel, ABS, etc. Okay, digital view. So a bit of research on type of the physical impact person. So from elderly and sports person, a mix of elderly and normal people. And the focus area is on the person customize the mobility design with a nature-born physical impaired person. According to say, session W2018, the drug phocomelia with PPFD is characterized by severe symmetrical limb reduction. Okay, so several symptoms are associated with this finding is Robert syndrome, uh, cytopia with absent radius syndrome, Rep syndrome, Warderman syndrome, whole arm syndrome. Okay, so these five uh, symptom with shown underneath, so can be associated with tetraphocomelia. Okay, what is tetraphocomelia? According to J. Clean Dice 2015, fatal limb defect are known to occur, although including in the rare category. Amelia is a condition in which one arm or leg is absent. It is also known as phocomelia. In this term was used first time in 1836 by Etienne Geoffroy Saint Hilaire. Okay, when all of these four limbs are affected, it's known as tetraphocomelia, which is tetra equal to four, phoco equal to seal and malus, malus equal to limb. In this condition, hand and feet are only part of limb, or shoulder or pelvis like seal flipper, so the leg. So this is the situation of the baby. So in nature born. And then next, okay, PPFD. Uh, Professor Karala Subaru defined it as a rare congenital disorder affecting the hips bone. So he added the spectrum of imaging finds range from mild femoral shortening with various deformities to complete absence of the bone. So here you can see the example of the PPFD. Okay. All right. Next, we go straight to the user. So this is the user. Okay, Adik Damia. So the case study, and then the data, the detailed data of this person. So on the school scene, and then in the house, and how the difficulty that this child face. Okay, daily activities, difficulty in writing, difficulty in moving. Okay, drinking, eating. Okay, this is very detailed. So this is the previous wheelchair, and we can see it later in detail. Okay, so this is the scene how um, the activity been done in school. Okay, so a bit embarrassing. Okay, so dedicated for her to write on the table. Okay, this is the father and this is the family. Yeah, this is at home. So activities, how the child been trained. Okay, so reading, writing, okay, so forth. And this is the proof that mentioned that talking about the person with this um, previous wheelchair, which is very designed, very engineering, so that is that didn't have the soul. I mean the aesthetic value. Okay, and based on this, as the first start, so the most important thing is to get the dimension. So ergonomic study. Okay, so whereby the dimension, once we get the dimension, and then we will give the approximate size to the bucket arm shell for the seat. Okay, and then this is to show that the other PWDS who suffering from Tetra phocomelia, so overseas. Okay, so this is based on the defect on the existing motorized wheelchair. So if you can see, so a lot of it's very crooked and very, if you can see, heavy and very engineering and very squarish. There is no the element of economics and the element of safety. Okay, so if you can see the system at the back, so they're using the pulley system. Okay, mechanism package. Okay, what if once this thing break, and then the whole thing will collapse down? So it's very insecure. So therefore, the things that need to be revised based on the observation is bulky form, no safety features, no ergonomics, not comfortable, unfoldable. Okay, because it is very static. Okay, so system not reliable, heavy duty, using stainless steel as structure. Okay, so okay, this is the thing to be improved in existing motorized wheelchair, which is the battery itself. They're using the normal motor battery, so to be put at both sides. Okay, so which is a bit bulky. And then this is the system that they use. Okay, pulley system, car pulley system. So which is very unsafe. I mean, even though it's very rough and tough. So, what if one day, because this thing is exposed to outside, all right? Okay, so and this is um, maximum height on the existing motorized vehicle. So, in terms of the height, it can goes, okay, and you can see this is how the things look like. And then problem of transportation. Okay, so the trolley to the transport, uh, transporting the wheelchair has been made due to first heavy weight of the stainless steel material itself, and then the static structure, okay, which cannot be folded. So because this is been done uh, non-moving, okay, cannot be folded. So resulting in a trolley that attached at the back of the vehicle might be insufficient. You can see uh, if this being carried by 4x4 is okay, but if this being carried by normal my V, I think it should be not feasible. Okay, then we moving to the detail of usability of control panel up and down. So mainly for the user, okay, how they operate, okay, the position. Okay, most of the thing is very sharp, so it might hurt the, you know, in terms of form it's very sharp, so no curve edges, so it's create a unfriendly image to the user. Okay, if you can see usability between user and existing wheelchair. Okay, so the next, so done for the um, existing investigation of the existing wheelchair. So now go to market research. So preliminary research process, you are using design thinking process. In this research phase, instead of evaluating the existing wheelchair design and listed the defect, the team also have undergo the brainstorming process in trash out the possible solution. Okay, on what plan the team will undergo the thinking process like mind mapping and then theoretical framework, and we go to the detailed tasks. So this is the aim of the step by observation, and then stage one. So we list down. So the aim and step taken by user to operate the motorized vehicle by themselves. So how it going to achieve? So based on this, we sum out the process, okay, for us to set the target. Okay, next, in based on the field research, most of the most of the wheelchair found, even though it is in various design, it is not dedicated to this kind of people. So it more towards elderly and people involved in accident. Okay, even up to this. Okay, based on field research, most of the price are expensive and depend on the complexity. Okay, so the price. So as for this model, you can see the price is up to 170K based on the usage of aluminum material, and then the technology, the motors, okay, and then all the gadgets and the functionality. So this what make and then it's customized to certain people. So this is what make the things very expensive, even though the customized motors is, as you can see, at the back. Okay, other types. So we search for the system, how the working system work. So in achieve the foldable, okay, and then the accessories, how they put the control panel, how they put the battery, okay, and then how they flip this for ease of transport, okay. Based on this, we can conclude that in market they have three types of wheelchair, or we can say mobility design system, which is a manual wheelchair, which is lightweight and for cater for normal people, an electric motorized wheelchair, all right, and a smart wheelchair, so which more towards gadgets, electronics, and so forth. So, so these range are very expensive. Okay, it all can up to the range of more than 100K. Okay, so as for our study, okay, by doing the mapping, we are focusing in between electrical motorized wheelchair and smart wheelchair. So the design focus area is should be industrial design driven, and then reasonable cost factors and affordable of the moderate user to own the products. So this is the area of product mapping. Okay. So next, up to concept design validation by design expert. Okay, the design process. So after evaluating the market and then digesting the study of existing wheelchair, so the designers have to sit down on the board and to produce the concept design. So a concept design idea generation is a preliminary concept ideation that have been made based on the research output. Research design illustration give the different approach of the working system. In this design stage, the aim is to select the most suitable concept to be further developed. Okay, the team of 10 mixed designers and engineers are participate in this idea selection. The design will be presented to them, and the decision will be made. Okay, based on this, the consensus towards design selection by the team. Okay, so as you see, so hydraulic concept. So this is number two that we are aiming for. All right, based on the three ideation. So which we can illustrate on this pie chart. Okay, result of the consensus and selection by wheelchair team members, which resulting um, okay of two area, which is it must be up and down, and it must be ease of transport. That means it must be foldable. So this is our aim: building the prototype within the university ground. Okay, so as for first, what we do is we sourcing for working mechanism, which is because the first phase is to do a proof of concept. So and then we in the initial stage of designing wheelchair, the most important criteria is to establish the reliable system for the user to move around. The solution is either to appear in mechanical or electrical solution. In this case, the researcher need to consider two new criteria, okay, which is either mechanical or electrical in P.O.C. So we decided to use the electrical auto jack lifter attached to the wheelchair to lift up and down the bucket seat. So the car jack system has been selected based on the ability to lift the weight of a car. that lifter are available to extend the height of approximately 8 inches from the ground. Therefore, the in terms of weight is already proven as devices are able to lift the car. So the concept of wheelchair configuration are according to the previous wheelchair design. Okay. So this is the preliminary design concept. So that means the mechanism been put at the back, all right, and then using this by the motors, lift up and down. Okay, this is for the proof of concept. Okay, so this is been at work. Once we do it, we bought a unit of wheelchair that very near to the to what we want, and then we tear off we and then we rebuild again. Okay, so we try to do according to what our aim, but uh, by seeing the facilities of university, so it is unable to produce the exactly that the reliable frame that what we want due to so therefore this thing can just prove the concept of lifting up and down, but in terms of the total solution, so we need to go back to the whiteboard and to redesign the proven system. Okay, so the failure design solution breakdown. Why? Because the concept is not using the right material. Okay, so most of the material that in house is normally normal fine steel, not to the spec of aluminium, high grade aluminium, not using the right lifting system, not using the right holding mechanism for balancing, incorrect center gravity, so two seat to be adjust, okay, and few others. So therefore, we listed here. So seat and frame finish assembly. So this is the point that we need to upgrade. So based on grant number one, so we have completed the proof of concept, but this is the part that failed. We need to be careful and redesign back in the second prototype. So the second run is to build a working prototype and redesign the second version prototype, main system and equipment use. So in getting the reliable source mechanism, so we are aiming on electric actuator. Okay, based on the team discussion, the next reliable system was electric actuator that runs on DC mode. The electric actuator device was eventually stabilized, used at home automation and testing equipment. It can be found in testing equipment lab. There were two types of actuator, which was meant for AC and DC, so that can be used for the wheelchair. So if you can see, this is the actuator. Okay, the external, and then we're proposing the external battery. Okay, as a backup. Okay, this is the and then we go for refining the design. Okay, going to 3D modeling and then restructuring. Okay, and then through here, through the scale grid drawing, we determine how high it can goes, how up and down, and then we have this to flip. Okay, so considering the three criteria that we set earlier. Okay, this is to preliminary to set, okay, the width of the uh, okay, the width of the wheelchair. Okay, and then still in the sourcing process. So then we found out the raw material, okay, which is alloy 2024. So this material proposed was a high-grade aluminium that used to build aircraft parts, a common high-strength aluminium alloy. It can it comes with a combination of high strength and excellent fatigue resistant. It is commonly used where a good strength to weight ratio of desire. So this is the um, okay the characteristic. The strength is high, and then other supporting building the structure. Okay, due to this, the team have to engage the industries, okay, in order to fabricate the reliable frame and system. So, but still, the design will be led by the design team. So, based on this, we select Ikramatic as our partners. So the frame construction are divided into two, which is upper frame and lower frame. Okay, upper frame, as you can see here, so it is for the upper part. It can lift up and down. It can support the seat, and lower frame is consists of the tires and all those electrical system. Okay, framing construction. In this stage, both frame will be assembled together and start installing the accessories such as battery, wiring, actuator system for testing purposes. The wheelchair design will be undergo the final stage of sub-assembly. After this stage, the focus will be on the functionality test. The testing will be done in-house. The wiring assembly will be completed and will continue on the testing and performance on the installation of electric equator as lifting system. The next stage will be the user evaluation test. In this test, the user will operate the wheelchair independently. So you can see this is the detail of assembly. Okay, so they will test the functionality in terms of moving front, back, round. Okay, and this is the equator they put underneath. Okay, okay, the first user testing. As per picture above, the team are fine-tuning the system, lifting test and background bending to achieve user requirement. So lightweight material, we use aluminium, okay, high-grade aluminium, using equator to elevating the base of teeth level, okay, equator. This is equator. Foldable, as you can see, this is foldable. So we have meet three criteria. So therefore, this thing can be put inside the car. Okay. In order to confirm the comfort of ergonomics, the team are organizing user testing session. This session, the user will be able to test and confirm the most comfort area. After this confirmation, the design will be freeze. Prototype will then be separated to parts and to be sent for body painting based on the color preference. Okay, so this is the user testing. As per deadline, the user has come to perform the first testing. Based on the picture shows, there are still some areas that need to improve, especially on the self-lifting area. Okay, so because our target is for the user to self manage the wheelchair for themselves. Okay, so this is where this area we need to change. The first we design as a stairs, but the user cannot climb due to the difficulty of have uh, the defect that they have. Okay, as per picture shown, based on user comment, the team will fine tuning, okay, the stairs, the fixed location, and reposition of the listing button, ground to seat level, so up and down. So this thing will go up and down. Okay, the second user testing. So this is preliminary, the color that we propose to the client. Okay, and then the user interested on this color, blue color. So and then we do some modification on these two areas, the stairs and the uh, okay, this thing, and then we bend it so that easy to push and pull. So and this one we do the proper bracket, okay, and this lifting area we change from stairs to platform. Okay, so this is the total final of the outcome. Okay, the aim of the design is to enable the user to self-operate. Okay, self-operate wheelchair and to maneuver freely without any assistance. So that is the aim. So afterward, I show you the video. So how this user manage herself, okay, to maneuver without any interference. Okay, knowledge contribution in this expected result. Number first is documented user characteristic on this particular person. So which having a very unique kind of um, symptom, Tetra with PPFD. And then number two is really using pushing the industrial design specification and documentation, meaning this is design driven. This is not engineering driven because it's more emphasis on economics, even though we are using most of the things, but most of the things are in the form of electrical and mechanical. But in terms of comfort and in terms of nice looking aesthetic, so the industrial design lead the process. And then number three is as the manufacturer reference to optimize the system specification for mobility design so that they can participate in involving themselves in creating local product, local design. Okay, discussion. The aim is to enable the user to self-operate. Evaluation outcome. Some area are needed to be refined to allow the user to maneuver freely. Okay, to assess the education learning within the school area, and then the refinement work will still be ongoing. Okay, so until the next testing. So conclusion, design outcome. The design developed carry resemblance of industrial design concept aimed as solution based. The design outcome focusing on safety, stability of material, economic factors, form and aesthetic. There were many of the potential design solutions produced in projects which are mainly prototypes and cannot be commercialized. Okay, so this is the dilemma of design of industrial designers because they produce only prototypes. So and then it cannot be produced. So the need is to establish the need of establishing center of design. So which a lot of work. Uh, so in building the design, so there's a lot of works and fund are needed before the design is ready for commercial production. A standard qualification required to achieve industrial standard reliability testing and mass production. As a product mass produced, will lower product price per unit. The user will then afford to buy the product produced for reasonable price. Expected benefit for user able to maneuver and customize their design with affordable mobility design system with inclusive design concept. So for the designers, the knowledge gain uh, for the PWDS, okay, will be the reference and guidance for other designers to continue studies in that area. Number three, for the public awareness, the application of inclusive design concept within the community-based product will increase the public awareness such as mobility design system for PWDS with PFD, a special group of people which also have the right to improvise their daily life. By having public awareness upon community service, there will be more inclusive design-based product cater for other type of people, not only PWDS. For the manufacturer, manufacturing opportunities as becoming a benchmark to pursue new range of inclusive design-based product to create the new opportunity for small group of people, whether they are elderly, PWDS, or other means of disabilities. Okay, so this is the last. This is the final product that has been presented to the Sultan Mizan and Sultana in one occasion. So, and this is the comparison between the previous and the um, and the new design. Okay, so this is one of the video clip. Okay, thank you very much. This is thank you for the presentation. Okay, thank you very much.
you very much, Mr. Ahmad Fairuz Ariff, for the very interesting presentation. So I know that all design students here will get knowledge with the how you want to do with the research, to start with the research, and how you want to come up with your product with verifications, and how you want to use the standard materials. We cannot just choose simply materials after we design, so we need to follow the spec actually. So without further our time, so we open the Q&A session. If you have any question, you may to send the text in the chat box, or maybe you can unmute your microphone, so you can direct maybe direct send your question with Mr. Fairuz. Silakan jika ada sesiapa soal yang ingin beri soalan. Okay, uh, before we receive the question from the audience, how much the exactly total cost for this wheelchair, Encik Ahmad Fairuz?
In actual, it will burst to 80K in actual.
80.
Yeah,
80 or 18? 80.
80.
80 is
Yeah,
quite a lot. So maybe because this is just one off, it's a
yes,
customized.
yeah, customized. So if
Okay.
we going to we are doing mass production, so the material cost, especially on the aluminum, will go down. So and then it might save a lot. It might go to,
Okay.
let's say, maybe 50K, half of that, or lower.
Yeah. Okay. Thank you very much. So we have one question from Prof. Razif Muhammad. You can read in the chat box there. Thank you for sharing, Saudara Ahmad Fairuz. The question is, does the design driven automation vehicle include such facilities as scanning or descanning stairs when needed or necessaries, maneuvering on a rough terrain? And so what is your answer, Mr. Ahmad Fairuz?
Okay, this is okay. Basically, when we say customizing the wheelchair, so there's a lot of situation. So it cannot be one off. We cannot solve the problem from A to Z. So it must be selective. As what we are doing in the wheelchair is cater for in-house and outdoor. So in the short distance, uh, if the question is how is it when it go to terrain, so that is another design that another area need to be venture, or we need to add in another consideration.
Yeah.
So yeah, so it's depend on the customization.
Okay, so is it any further research after this about this project?
Yeah, so based on my PhD, so I have widened my scope. So it's not only Tetra phocomelia. Okay, Tetra phocomelia is child born with incomplete
Mm-hmm.
hand and leg. So whereby PPFD is the incomplete of the the bone. Okay, so which also can be associated to other um, other PWDS that within, I mean, sharing the symptom. So for example, as I shown just now, so there's a 5 to 6 group of user. So as a designer, we did not only design only for one person. So it is sebab tu yang therefore the cost will be incurred higher if we design for customization. If we can design for mass production and we can cater for a certain group, Okay, it the price will be a bit lower.
Okay. Before that, Mr. Ahmad Fairuz, can you unshare your slide presentation now
Okay.
so we can clearly look at your face. So, is it any question? Yeah, from our dean, Dr. Mumtaz. It's a wonderful sharing session, Mr. Fairuz. I would just like to ask what are the feedback and response from the parents and the caretakers.
Okay, actually, they are very happy because the first thing is the humiliation that they face when I mean, where it is good that they have already established a um, previous wheelchair, but here again, um, it's quite embarrassing because as you see, it's not coming from us, the designers, but they themselves say that I mean, people perception towards
Mm-hmm.
all this kind of robotic
Mm-hmm.
so called in term of form. So they there is no the element of friendliness, the element of aesthetics built in. So therefore, so in this kind of research of community research inclusive design and the element of um, aesthetic must be put inside. So this is where the value of a designers lies in.
Yeah.
Yeah,
Yeah, for it's look like from the first design, it's look like not commercial value at all, I think, if I'm not
yeah,
mistake, because we need to put aesthetic value and all the design element so that we can promote the chairs and also the users itself. Tak adalah dia nampak kaku kan. Uh,
uh,
okay. Any question from the Facebook, Dr. Sarina, or maybe where you meet this girl, this little girl, Encik Ahmad Fairuz,
okay.
with this problem?
Actually, they come to us.
Oh,
So,
okay.
because based on the uh, previous wheelchair makers, so they don't did because they did not know how to make the wheelchair. They do not put how to put the aesthetic value on the wheelchair. So, I mean, that investment carry to the family. So because another one thing is the family is uh, one of the MB Tengganu relative. So I mean they need to to make sure all the things are nice looking. So therefore, uh, so even though it's customized,
Yeah. So, is it the family just customized by themselves the previous wheelchair?
the previous wheelchair been done by Zul Design. So Zul
Okay.
Design they are more towards engineering solution.
Yeah.
So it's very crude and very rough. So that's therefore Zul Design introduced the family to us. So
Yes.
then we take the challenge to produce the design.
Yeah. Thank you very much. So, any other question from the audience, from the question, from the student, from students? Maybe you have any question? Or maybe after this, if we have a question from the audience, they will put in the our FB live stream. So maybe Encik Fairuz will answer from the FB live later.
Yeah.
And Dr. Muntaz said, I must say this is a novel research project that directly contributes to the community. Yes, I agree with that. So, what is the any before we end this session? I think they have no question. So, before we end this session, what is your last words from you for these projects?
For my
Maybe
that
your
means for me.
experience. Yeah. The last words before we end this session.
Okay. This is where I mean the designers need to take the challenge of that means the designers especially the student so must take seriously what been taught within the universities, and in terms of the design. So they must digest as much as possible, because out there, so you don't have this kind of opportunity. So it is very important for you to grab hold for all the knowledge that been equipped to all the lectures in USM lah.
Okay, last question we got from Dr. Sarina. How many kilos is the wheelchair?
Okay, the existing wheelchair is more than 100 kilos.
Wow.
So we managed to squeeze it to 50 kg.
Okay.
Yeah.
50 kg is still how they carry to the school. Is it comfortable,
Okay.
collapsible?
Yeah, collapsible. As you see just now, so it's
Yeah.
collapsible, and then it can be put inside the car. So
Is
during
it
our transportation from KL to Terengganu, so we put that things inside our car, and then transport, go back to Terengganu.
if 50 kg? So when they want to hold and angkat 50 kg from the bonnet, from the to the car or inside the car and go up. So is it for the woman like me? Maybe I'm not carry that very heavy. So
Mhm.
it must somebody will just maybe it's the what penjaga dia
Okay.
ke kan
Yeah,
yang
yeah.
need to help.
Mm. So the reason it must have the weight, because it must remain the stability, because if it is too light, then afraid that we cannot balance up for other equipment. So we have batteries, we have other things, the bucket. So it also need to be firm when we put. So that's why.
Okay, so I think they have no question from the Facebook or from the chats box here.
Okay.
So we can end this session. And thank you very much for your time, Encik Ahmad Fairuz. And also thank you very much to all of you, all the participants here. And inshallah we'll meet again next month with our another presenter in ROF. So thank you very much. See you again. Assalamualaikum.
Waalaikumsalam.